But what we were more interested in, of course, was seeing, well, how will this change across the next 100 years? What does the next century have to offer? So we created a model where we examined what would happen to 100 eggs over a season. And you can see here, the eggs are in yellow, the larvae are various colours, the larval stages, various colours, blues and purples, the pupae are green and the adults are black. And this is the current situation. So you can see sometime in May, early June, the eggs hatch, they convert to larvae, and the larvae finally convert to pupae, and then they go to adults. But actually, very few are able to develop in a single season. I think there are only 7 there that can develop to a single season, and this is because it's not warm enough at the moment for these insects to develop effectively. However, if we look in the future, we see in the future it's much more dramatic. 100 years on, what's going to happen is almost all the eggs are going to hatch. So we expect a huge increase in the insect population in the future. So is that really possible? So looking here at another insect, the woolly bear, the carpet beetle larvae, what happens there is it seems quite sensitive to temperature. And so if you predicted how many you would get in the future, how many you would catch in buildings in the future, there's a very dramatic rise as temperatures increase across the current century. So what that means is that we would expect large numbers of carpet beetles, enormous numbers of carpet beetles, so many carpet beetles that it seems really quite impossible. So what's happening? The predictions seem likely to be correct, but things would become in short supply. Would there be enough food for all these carpet beetles to develop? So it's not just a climate effect. We've got to think of other things that control insect growth. So, for example, food availability is of course one, but what about niche? What about the habitat, the niche, the space for the insect to occupy? There might not be enough suitable habitats for the population to really explode. They might get disturbed. There may be new predators that affect these insects. And particularly in historic buildings, we don't quite know always how they're used. So many historic buildings are used for things like wedding, where food availability might increase if there's a wedding, and we simply don't know about these factors, but they're certainly not really climatic. So we always have to remember, while climate is an important driver, there are likely to be other factors. So we used the COVID crisis to look at museums at a time when there was little disturbance. Museums were closed. And so we reasoned that perhaps very shy insects would find this very useful. They'd range more widely. They would come out a little bit more when the museums were quiet. There'd be a lack of maintenance, so things wouldn't be moved and they could take advantage of new habitats. So we tracked the silverfish, and sure enough, during COVID, you can see from those little lines of 3 species of silverfish in 4 museums largely increased in the period of the COVID closures, showing that the insects really did appreciate the quieter times when the museums were closed and were able to extend their range and perhaps in case of some insects, even increase in numbers, even though the period for that breeding was rather short. There's another issue that seems to be related to climate, but is still rather complex. What about the difference between insects that live in urban heritage buildings and rural heritage buildings? So we chose libraries in Austria, very large monastic libraries in big historic buildings. Obviously, libraries are useful because they have a very fixed collection. They basically store books. So there's just one kind of object, really, stored within the libraries. So we looked at these large historic buildings on this rural to urban transect, and what you find is a lot more insects were being caught each year in the rural libraries than in the urban libraries. So you might say, well, that's a little bit odd because surely cities are warmer. Why aren't there more insects, a greater abundance of insects in the urban buildings? Well, you can look at it in a little more detail. So here you see the change in some anthrenous species of beetles, and what you find is even the species that are found changes very much between the rural libraries and the urban libraries. They're really quite distinct. So it's not just at a level of the number of insects, it's also at a level of the kind of species that you find in a given genus. And another surprise, there are more species in the urban areas. So more species, the species are richer. There are like 20, 30 species in some urban locations, but in rural locations or in smaller buildings, there's less number of different species. There's a less species richness. You might say, well, that's rather odd. Surely the countryside should be more diverse. The countryside should have a greater range of insects. But in fact, if you look at the insect types, what it means is in the cities, there are more invasive insects. More insects are being brought into cities. More new insects come into cities than into the remoter rural areas. And in fact, another reason may be there's more pesticide use in the farms that surround these rural libraries. And just to show you how confusing it might be, this is a beetle that's very much on the increase. This beetle, Risa vespulae, the skin beetle that attacks particularly leather objects. It also attacks insect collections. So this beetle is growing very rapidly in a number of countries. It's certainly well known in North America. It's growing in numbers in Europe. And so this particular beetle is very interesting because the rapidity of growth in this data here in the graph on the right shows a really great increase in the number of these beetles. And you could say, well, is this due to climate change? No, it's just far too rapid for climate change. The reason this beetle is growing so rapidly is more likely it's being more frequently introduced from North America, where it originated. So that's really what I want to say about insects and biology and its effect on heritage.